Okay, AP Calculus, this is where we left off on Wednesday. So we're just going to focus today's asynchronous lesson on finishing this lesson. And we'll pick up on Monday, hopefully with stable power and internet here at mine. I do apologize for it. It was 2 times actually that the power went out, and we're just trying to avoid abruptly ending class, because of a power outage. Anyway, so example 5 says, given h of x, we have this piecewise function here. For what values of x is h of x not continuous? Okay, so where is it not continuous? Now, recall our properties of limited continuity here of polynomials, right? Each piece is continuous because polynomials are continuous everywhere. We have a linear function, constant, and a cubic. These are all just polynomials, okay? Now, went ahead and sketched a graph here, right? Here's my linear function, the first piece, negative slope, right? For all x's, less than -2, so this direction. Then I have a point at at -2, -3. The y value is 3, the x value is -2, right? So it's just a point, -2, 3 there. And then we have this cubic function, so I just went ahead and sketched it there. At -2, if I plug in -2 here, I get -8, plus 12, that's +4, 4 plus 3 is 7. So it's definitely not on the close point. So here's just a sketch of the graph, okay? So we got to investigate the behavior at x is equal to -2, okay? The justification here would be h of -2 is 3. That's what's in the domain, okay, given by the piecewise function. The limit as h of x approaches -2 does not exist. Why? Because the limit of h of x, as you approach -2 from the negative side, you approach -1. How do I know it's -1? Plug in -2 to the first piece. I get +4 minus 5, that's -1. Okay, so that's this one here. The limit as h of x approaches -2 from the positive side, you'd be on this piece here. We had already investigated that one to be 7. So both sided limits are different, therefore the general limit does not exist. Okay? Since the general limit does not exist and it's not equal to h of -2, therefore your conclusion is that h of x is not continuous at x is equal to -2. Okay? So this here is what's definitely necessary. Okay? The graph, because we are handy with how our functions look like, we were able to sketch something to also show it. But if you didn't have the graph, this right here would describe it to your reader perfectly. Okay. Next example says, use 3-part definition of continuity to create a system of equations, then find the values of a and b so that f of x is continuous for all real numbers. This is similar to some of the stuff we had done last year. Okay, we need to figure out for what values a and b this piecewise function will be continuous. Okay, continuous for all real numbers. So this piece here ends at -1, right? -1 is not in the domain of the first piece. However, -1 is in the domain of f of x because we have a point at -1, 6, right? And then after -1, you have the piece down here, this quadratic, right? Now, if you're going to have continuity, that means this left-hand limit and this middle piece, right, have to be the same. The limit as x approaches -1, that y value has to be 6. -1, 6 is this piece right here, right? If they're the same, then they're meeting, they're connecting, right? If they were different, then they'd be separate. So then what are you going to do? You can plug in -1 here, right? If you plug in -1, you're going to get -2a minus b. -2a minus b needs to be equal to the limit here for this middle piece, which is 6, because it's just a point, right? So -2a minus b has to equal to 6, so that these two pieces connect. Same idea, this piece and this middle piece, the third piece and the middle piece, the second piece, they need to connect also, right? So then, we already know this one's just a point at -1, 6. We need to make sure this guy has a y value of 6 also. So then, when you plug in -1 here, -1 squared is just +1, so a. So then it's just a plus b. So that's this equation here. And that needs to be equal to 6, right? -1, 6, the y value, so that they're connecting. So if this piece here is connecting here, and this piece here is connecting here, that means then they're all connected, right, at a closed circle of the middle piece. Okay, that's the two equations I have right here. Here's between the first piece and the second piece, between the second piece and the third piece. Okay, so then I can set up a system of equations and solve, right? Notice that I already have a negative b and a positive b, so all I have to do is just add the two equations. A minus 2a is negative a, 6 plus 6 is 12, so then I find that a is negative 12, so that's one answer already. Okay, then just take it and plug it into any of the equations, right, and then you find your second answer. B is equal to 18. Okay, this right here further serves to explain, right, that the left-hand side, the left limit from the left-hand side needs to approach 6. The right-hand side, the right-hand limit also needs to approach 6 because f of negative 1 is 6. We need all pieces to connect. Okay, so this serves as an additional justification of our work. Finally, before I show the rest there, it says, you know that the function value and the limit value can exist independently of each other. That summarize the big ideas of continuity on intervals, at points, and one-sided limits. So given g of x, and we have this piecewise here, find each of the following. We have the limit as x approaches 3 from the left side. Right, here's 3. From the left side, that'd be the first piece. So what's the limit? Plug it in. 2 times 3 is 6, plus 1, 7. So then the limit as x approaches 3 from the left side, g of x is 7. Similarly, the second piece represents the right side. So then the limit as x approaches 3 from the right side of g of x, plug it in, you're going to get 9. Right, it's just 3 squared. G of 3 is, so what is g of 3 though? G of 3, well, x is equal to 3 is actually in the domain of the second piece. Right here, no, because it's not equal to 3. Here, yes. So then g of 3 is actually 9, right? So then both sided limits are different, sorry. So then the general limit as x approaches 3 will not exist. Okay? Is g of x continuous at x is equal to 3? Justify. G of x is, oops, sorry guys, just realized I had not scrolled it down. Sorry, so here's this one. Here's part D. The limit of g of x does not exist because again the general limits were different. The last one says if g of x is g of x continuous at x is equal to 3? Justify. So g of x is not continuous because, right, both sided limits were different, right? They were not equal, and the general limit, right, is definitely not g of 3. It does not exist. G of 3 was 9. Okay. So then the summary in this lesson here is if a function is continuous at a point, then the function value and the limit value are the same at that point. Okay. That wraps up this lesson. You can now finish the assignment. The assignment for this concept will be due on Sunday. Okay. I'm also thinking next week will probably be the last week of lecture for the quarter. The 2 weeks that follow after that will be all testing. Okay. Later today or tomorrow Saturday, I will be posting your unit review. Okay. So feel free to start working on that and study. Okay, because there won't be any retakes.